Good day guys, this is your tutor engineer. Today we are continuing with our lesson series on geometry. Let's start with today's lesson. In the diagram below, point A, B and C are vertices of triangle ABC. AD is drawn in such a way that point D is the midpoint to BC. The first question, determine the gradient of BC. Okay, let's just choose a color for that. So 3.1 gradient for BC. The formula is y at B minus y at C divided by x at B minus x at C. So y at B is 2, y at C is 6, so we'll have here 2 minus 6 divided by x at B is minus 8, x at C is 4. Here we'll have minus 8 minus 4. The numerator will work out as minus 4. The denominator is minus 12. So you'll have 1 over 3 as your gradient. So let's go to the next question. Determine the length for BC. You first need to write the formula for the length. Y at B minus y at C squared plus x at B minus x at C squared. All of that under a square root. That's the formula. So y at B, we've already established that is 2 minus 6. Then x at B, you'll have here in this bracket minus 8 minus 4 squared. And then here it's minus 4 squared plus minus 12 squared. 16 plus 144 square root. Okay, so you will have square root of 160, which is approximately, if you punch it on the calculator, you will get 12.6 units as a length. Okay, so that's how you work out question 3.2. Then question 3.3, calculate, determine the value of k. So that value there. Okay, let's just choose a different color for question 3.3. That's the value you need to determine. 3.3. Okay, what do we know? We know that the gradient for BC is the same as the gradient for BD, since they are both on a straight line. So here we can write the gradient for BC is equal to gradient for BD. They are both equal to 1 over 3. So the gradient for BD we can work out as y at B minus y at D divided by x at B minus x at D, 1 over 3. Y at B is 2, y at D is k, divided by x at B will have minus 8, x at D is minus 2. Then all of that is equal to 1 over 3. So let's just work out by basic mathematics. Here you can cross multiply from this point. Then divide both sides of the equation. Then you take 2 to the right hand side, which is going to be minus k is minus 4. Therefore here you can conclude that k is 4. Okay, so let's go to the next question. Determine the value. Okay, we've already determined. The next question is 2.4. If AD is perpendicular to BC, show that AD is perpendicular to BC. Okay, we already know the laws of perpendicular lines. One condition that you must meet is when you multiply the gradient for AD times the gradient for BC, they must give you -1. That's the condition you're trying to fulfill. You've already worked out the gradient for BC, but you don't know the gradient for AD, so let's work it out. Gradient for AD, y at A minus y at D, divided by x at A minus ax at D. So, okay, let's just write underneath. Y at A is 7, y at D is k, which is k we've worked out as 4, x at A minus 3, x at D minus 2. So the numerator will have 3, then the denominator of -3 plus 2. The answer is 3 over -1, which is just -3. So let's now make a conclusion. Let's choose a different color. This gradient here worked out as -3. This one is 1 over 3. So the condition is met when you multiply -3 times 1 over 3, you get -1. Therefore, you can conclude that AD is perpendicular to BC. Okay, now let's go to the next part of our next question altogether. Okay, so this question says the roof of a canvas tent is in the shape of a right pyramid having the perpendicular height of 0.8 meters on a square base. The length of one side of the base is 3 meters. The first question is calculate the length for AH. Okay, let's quickly work out the length for AH. Let's write 7.1.1 right here. So we know this is AH from the diagram. So the height, let's just make a little drawing. We're just going to view it on a 2D. Viewing the roof of the canvas on a 2D, you've got something like that. Then this is the height. The height you are given that it's 0.8 meters. And then this length here is half of 3, since the entire length of the roof is 3 meters. So this one is 1 over 5. So this is H, this is H here, and this is A there on top. Let's calculate this length. The theorem of Pythagoras should spring to mind. So AH, okay, let's write here. AH squared is equal to the height squared plus the length 1.5 squared. So AH squared is equal to, so 0.8 squared, punching all of that in a calculator, you get 2.89. So you take a square root sign on both sides, then AH is 1.7 meters. So that one is 1.7 meters. And then the next question is calculate the surface area of the roof. Okay, let's write 7.1.2 here. The surface area of the roof. We've already worked out the one face of the roof. Basically, the roof has got 4 faces of our triangles. This is the triangle, 4 faces of them. So to work out the surface area, Let's first calculate the area of this particular triangle. The area of a triangle is half base times height. Here is half, and then the base, remember, is going to be the entire length, which is 3 meters. So the base is 3 meters, and then the height is 0.8. The area is 0.8 times 3 times half, 1.2 square meters. So the total surface area is going to be 4 times area, since there are 4 faces, so it's 4 times 1.2. The answer would be 4.8 square meters. So that's the answer for question 7.1.2. Then let's go to 7.1.3. If the height of the wall of the tent is 2.1 meters, calculate the total amount of canvas required to make the tent if the floor is excluded. Okay, the total amount here they're asking us for a volume. Okay, basically we're going to work out the volume of the walls and the volume of the roof of the canvas. Let's start with the volume of the walls. So we've been given that the height here is 2.1 meters. So the volume will work out as V is equal to 2.1, which is the height, then the base is 3, and then that length over there is 3 meters as well. Okay, so the volume will work out to be 2.1 times 3 times 3, which is going to be 18.9 cubic meters. So if you want the total volume, you can also calculate the volume of the roof, which is your volume is equal to, it's going to be equal to 1/3 area times height. That's the volume of the pyramid, since our roof is a pyramid. So that would be 1/3 times the area is going to be 3 for that length, and also for the adjacent length is 3. So 3 by 3 is the area, the height is 0.8. So here 3 times 3 times 0.8 times 1/3. The volume is 2.4 cubic meters. Then the total volume for question 7, let's write here, total volume is equal to 18.9 plus 2.4, which is 21.3 cubic meters. Now let's say you were given to calculate the surface area for the very same question. Let's also work out the surface area. I'll show you how to calculate the surface area if you've got the walls and the height of the wall is 2.1. Okay, let me just go down here for space. Okay, let me just write next to our drawing itself. If you were to calculate the total surface area for the walls, okay, you need to calculate the area of one of the faces, and then you can multiply the faces by 4, since there are 4 of them. The area is equal to 2.1 times 3 basically. Then the area is going to be 2.1 times 3, which is 6.3 cubic square meters. That's the area for one face. Now, because you want the total surface area, I'm going to multiply that area by 4 times 6.3. You will get 25.2 square meters. That's the total surface area for the walls alone. So if you want to calculate the total surface area for the walls and the roof, you can just say TSA total is going to be 6.3 for the walls, plus, remember, we've already worked out for the roof on the previous question. This was the total surface area for the roof, so we'll add it here to 4.8. So 6.3. Okay, I'm sorry, here I made a mistake. Let me just correct that mistake. The total surface area for the wall is basically 25.2 plus 4.8. So the answer here, 25.2 plus 4.8, you get 30. So I was just showing you here if you had to calculate the total surface area instead of the volume for question 7.1.3. Okay, now let's move on to the next part of our question 7.2. The metal ball has a radius of 8 millimeters. Okay, what did I do here? Let's remove 8 millimeters. The volume for the sphere is this, the volume of the sphere. The first question is calculate the volume of a metal used to make this ball. Give your answer correct to 2 decimal places. Okay, the area of the volume, of the sphere. Let's just choose this color. First, let's visualize what you've been given. You basically have a sphere. The radius for the sphere is 8 millimeters. So you need to calculate the volume. You've been given the equation of the volume, the formula rather. So basically here you can say volume is equal to 4/3 pi times 8 cube. So what do you get? 8 cube times pi times 4/3. Your volume is 2144.7 cubic millimeters. Okay, since the answer is required in 2 decimal places, you can just write the answer is 0.66 instead of 0.7. Let's just do what we're asked to do here. So here you'll have 0.66 millimeter cube. Okay, the next question is, if the radius of the ball is doubled, write down the ratio of the new volume to the original volume. Okay, now we have a new volume divided by the original volume. So the new volume had been doubled. That means here you'll have the radius of the new volume had been doubled basically. So you'll have 4/3 pi times, we can just say 2r, all of that cube for the new volume. So this one will be divided to 4/3 pi r cube, which is the original volume. All right, so let's just continue our answer here. Okay, let's just write it in a way that you can all see it. So basically you have something like this. So we can further simplify this as basically 4/3 will divide each other. Let's just choose a red color. 4/3 and 4/3 will divide each other. A pi and a pi will divide each other. Then you'll be left with 2r cubed. Right here, 2r cubed is going to be 8r cubed divided by r cubed. So the ratio is 8. Alright, so that's question 7.2.2. And then question 7.2.3, you would like this ball to be silver plated to a thickness of 1 millimeters. What is the volume of the silver required? Give your answer correct to 2 decimal places. Okay, let's work that one out. Let's write here for the sake of the space 7.2.3. Okay, let's first picturize what you've been given. The original radius is 8 millimeters. Been told that there is another thickness of a silver plate 1 millimeters that will go around the ball. So basically we need to calculate the volume of the entire thickness of the silver plate. Okay, so let's calculate the volume together, and then we'll calculate the volume of the thickness of the plate itself. So the volume, the formula will remain the same. The radius will be the new radius. The new radius is going to be 8 plus 1, which is 9 millimeters. So to work out the volume here, 9 cubed, the answer would be 9 cubed times pi times 4/3 is 3053.62 to 2 decimal places cubic millimeters. So to conclude and answer the question, you will say the volume of the silver is equal to this volume, which is 3053.62, divided by the volume that you calculated before. Remember, under the first question we had the volume of 2144.66, which is going to be the volume of this part of the sphere. So here let's write 2144.66 to get the volume of the silver plate. The answer here is going to be 908, comma, you can say comma 97. That's the volume of the silver plate. Okay, I think this was the final part of the question. We've come to the end of today's lesson. If you liked today's lesson, please subscribe and stay tuned on the next lesson. Cheers.